10 materials that help to minimize greenhouse gas emissions by storing carbon. Carbon storing materials include bioplastic cladding and mycelium insulation. Sequestering carbon that has been removed from the atmosphere in buildings and commodities is one of the most effective strategies to mitigate climate change. This may be done by directly extracting atmospheric carbon from plant materials like wood and cork and using it. It can also be transformed into other materials that hold carbon for a longer duration. What if everything in our environment was built to absorb rather than release emissions? Made of Air turns agricultural and forest waste into carbon-negative bioplastics. The material is carbon-negative because it contains more carbon than was released during its synthesis and use. Climate change is a serious material problem. Climate change is a material concern in the sense that there is too much carbon in the atmosphere. So, why haven't we been able to turn it into our most precious asset? Carbon from factory chimneys and other greenhouse gas-emitting industrial operations is used in these items. However, such goods cannot be classified as carbon-negative since they do not result in a net reduction in atmospheric carbon. As part of a carbon revolution, how may this remarkable substance be extracted from the atmosphere and used on Earth? Here are 5 examples of carbon-storing materials from the past. Bioplastic. A German business, Made of Air, has developed a carbon-negative bioplastic that may be used in cars, interiors, and cladding. Biochar is a carbon-rich material made by burning biomass without oxygen, which helps to keep CO2 out of the environment. It would look the same if you placed charcoal on the ground and came back 1,000 years later. You could only release carbon if you burn it. The bioplastic was recently used to cover a car dealership, according to Made of Air, with the installation keeping 14 tons of carbon. Mycelium insulation. Mycelium insulation is being developed by Start UPS to provide naturally fire-resistant building insulation while simultaneously removing 16 tons of carbon from the environment every month as it grows. Mycelium, a biomaterial that makes up a fungus's root system, feeds on agricultural waste, sequestering carbon from the biomass in the process. The carbon-negative construction solution includes mycelium. It has a natural fire-retardant quality to it. It has better insulating properties than most other types of insulation and is carbon sequestered. Mycelium grows swiftly and is affordable to manufacture in custom-made bioreactors. It may be grown in molds to create useful objects like packaging and lights. It may also be made into novel materials, such as mylo, a leather-like material. Then it can be used to make handbags and clothes. Wood. A fully grown tree can remove 22 kilograms of CO2 over the course of a year, making the material carbon-negative if correctly procured, and the chopped tree is compensated by new planting. Any carbon stored in the wood must be weighed against emissions generated during transportation and processing, and replacement trees must be allowed to grow to the point where they may be harvested and converted into carbon-storing materials. However, one concern with wood is the large amount of waste produced by the timber industry. Only a small percentage of each tree is usable, and timber cutting generates a lot of waste and offcuts. In addition, only around 10% of all timber is recycled. 3D printed wood. An additive manufacturing business has developed a 3D printing filament created from sawdust and lignin discarded by the timber and paper industries. The company believes that by making goods out of rubbish, it will prevent additional trees from being cut down and waste wood from decaying or being burned, releasing carbon that has been contained. It has the capability of saving many trees. It's a lot of fun, as well as being rather useful. Olivine sand. Olivine, one of the most common minerals on Earth, is capable of absorbing its own mass in CO2 when broken and dispersed over the ground. This means it may be used as a fertilizer and a sand or gravel alternative in landscaping, and the carbonated form can be used as an additive in cement, paper, and 3D printing filament production. It is mentioned in an online library of carbon-capturing materials and easily absorbs CO2. 1 ton of olivine sand may absorb up to 1 ton of CO2, depending on the circumstances. You only need to spread it out now, and nature will take care of the rest. Concrete. By substituting emissions-intensive cement with waste slag from the steel industry, which accounts for 8% of all greenhouse gas emissions, a company has developed a type of concrete that traps carbon in its manufacturing process. The technology currently depends on collected industrial emissions, which implies that it reduces the amount of new emissions released into the atmosphere while leaving CO2 levels unchanged. The completed material, on the other hand, will be carbon negative when the company harvests CO2 from the atmosphere via direct air capture. It's a zero-emission technology, which means CO2 is eliminated from the system every time a block is constructed. Bricks. CO2 is injected into industrial waste, such as mine tailings, to turn it into a solid that can be used to produce cement bricks and other building materials. The procedure is based on the natural mineral carbonation process, in which carbon dioxide dissolves in rain and reacts with rocks to form new carbonate minerals. They're trying to incorporate emissions into as many elements of our everyday lives as they can. Companies can make money by recycling waste and CO2 to convert them into new things. Food. Solar Foods is one of a growing group of companies that create foods and drinks from industrial emissions. The Finnish company uses microbes to turn carbon dioxide into Solein, a meat substitute. The CO2, together with hydrogen and other nutrients, is injected into a fermentation tank, where the microorganisms feed and convert the CO2 into protein, which is then removed and dried, giving a powder that resembles dried soy. Carbon dioxide comes from industry, but it may one day be replaced by carbon captured from the atmosphere. If scaled up, the technology might fulfill humanity's protein needs while using a fraction of the land and resources now required by traditional agriculture, allowing more land to be used for afforestation, solar energy, and other climate change fighting activities. No agricultural inputs are used in the production of Solein. It does not need arable land or irrigation, and it is not dependent on weather conditions. Vodka. CO2 is used to create vodka by a firm named Airco. Carbon dioxide, water, and a proprietary catalyst are combined in a reactor to produce ethanol, which is then used to distill vodka. They devised a method for capturing extra carbon from the atmosphere and converting it into ultra-refined, valuable products. Industries produce CO2, and they can lower the greenhouse gas emissions they emit. Food and drink only store carbon for a short amount of time before being eaten and released into the atmosphere through the natural carbon cycle. Producing foods and drinks with captured CO2 is still a good way to store carbon inside consumable products. Chemicals, plastics from captured carbon. Researchers have developed a new polymer that can gather carbon dioxide molecules selectively and effectively convert them into valuable chemical compounds. They've developed a porous material with a high affinity for CO2 molecules and the capacity to convert it quickly and effectively into useful chemical compounds. One of the greenest methods of carbon capture is recycling carbon dioxide into high-value molecules like cyclic carbonates, which may be used in petrochemicals and pharmaceuticals. After trapping the carbon, the converted substance may be used to make polyurethane, a material with a wide range of applications, including clothing, home appliances, and packaging. This discovery emphasizes the potential of porous coordination polymers for collecting carbon dioxide and turning it into usable materials, paving the way for future carbon capture research and materials.